It's important that people understand this. You already said it. This has to do with good manufacturing practices. It also has to do with probably quite a few serious oopsies along the way. That's what I like to call them. When you make this modified mRNA at large scale, you've probably heard about the bait and switch. Have you heard about this?
The one that got approved was not what they were delivering, but they were passing it off as though it was and benefiting from the immunity that was granted to them.
Okay, that's a facet. But what I'm talking about is that the actual material, the starting material to produce the modified mRNA that was packaged in the LNPs in the clinical trial, the Pfizer clinical trial, was not the same as the commercial products. So when they needed to upscale this crap, and this is after the Pfizer trials, which are already horribly questionable, that data, they needed to save money and they needed to save time. So a really good way to produce a lot of product is to use plasmids, which are circular DNAs, and insert the gene for the spike, put those into bacteria like E. coli, and use the fact that the E. coli double every 20 minutes to exploit that power and make tons and tons and tons of DNA for use for in vitro transcription reactions to make modified mRNA. So this was the upscaling methodology that they used to synthesize this modified mRNA that saved them a lot of time and it saved them a lot of money. This isn't just mRNA that they were making in this in vitro synthesis reaction or in vitro transcription reaction. This was modified mRNA. Again, instead of uridines, which is one of the 4 bases, they substituted every single uridine in the sequence out for something called N1-methylpseudouridine. And they did this for very, very specific reasons.
Reproduce faster and made it cheaper to make more samples, I presume.
Well, no, actually, it was to make these transcripts more stable, basically, and evade the immune system, the innate responses like these things called toll-like receptors in the endosomes once they got into the cells. They're real smart about this. However, I don't think that they accounted for the fact that these things have higher melting temperature, which you don't need to know what that means. It basically, you can think of them as being really sticky. So once these bases bind to a complementary base, it's really hard to take them apart. So during the synthesis process, or the manufacturing process, the in vitro transcription reaction, when they threw in the N1-methylpseudouridine, there were little bits of DNA from the plasmid, and there were also mRNAs being made. So what we think happened is that those DNAs and mRNAs hybridized, because this happens. This is not something that doesn't happen in nature. It happens in us all the time. We actually have specific enzymes to break these things down, because if you have an accumulation of them, it can be really bad for the cell. So if this happened and these little hybrids formed, they're going to be really hard to take apart. And that's the problem, I think. Their own end-of-line manufacturing requires the removal of lipopolysaccharide, which is a toxin associated with the E. coli bacteria, and all DNA, right? This is the most important step, because you don't want to introduce all that DNA that was in the plasmid or the plasmids themselves into the final product, because you don't want to do that to a human being, because introducing foreign DNA in lipid nanoparticles is probably a bad idea. Lipopolysaccharide will induce anaphylactic shock in many cases. Does that sound familiar? So what we think happened is at this end stage, their enzyme called DNase 1 didn't work on these hybrids or the DNA that was left over. Somehow it didn't get removed. You're supposed to break it up, chew it up, and then filter it out. Didn't work. So these things must have gotten packaged with the modified mRNA into the lipid nanoparticles, and that's why we're seeing them in the vials. One of my slides that I show in my presentation about this demonstrates that the EMA knew that there was residual DNA in the vials, and they were trying to mitigate removal in, I think it was March 2021. Way at the beginning, they knew that there were excessive amounts of DNA. In my opinion, what they should have done is stopped making these things, certainly stop injecting people with them until they really do mitigate that problem, because it has unknown consequences to human beings.
This is back in 2022. Moderna recalling batch after foreign substance found in CMO. And I think
that was the metal, I think.
I think that was the metal one, illustrating the problem of mass production at a rushed and no quality control rate. Who was it that first discovered DNA in the jabs, or when was that?
Kevin McKernan. It was years ago now, I think. He used to work on the Human Genome Project. He has his own company called Medicinal Genomics. He's probably one of the most seriously mad, sick, intelligent people I've ever met. He's the first one to say he's not a doctor, which I think gives him a lot of street cred, because he went straight into industry. Like, he makes sequencers. Like, the guy is serious. I mean, he's kind of like supernatural when it comes to genomics. But yeah, he's not a PhD, which is probably why he's so talented, because he didn't get brainwashed by academia.
Well, there's the old expression that an expert is just someone who knows more and more about less and less. Bada bing, bada boom. Do you know what type of DNA? I mean, that's the question. Okay, and I think we do. It's SV40.
Yeah, so Kevin, he was just looking for, I think, a positive control for some other assay he was doing in his lab, and somebody had sent him these Pfizer vials, and he realized, oh, well, that might work as a good positive control. And it just kind of took it on its own life. Like, it's like once you see something, it's like, you have to keep looking. And once you see it, you can't look away. So he sequenced the genetic material in the vials. And the first time he did this, he found that like 1/3 of the genetic material was DNA, and not like it should have all pretty much been mRNA. He was like, no, this can't be right. And so he redoes his own work. He told a couple other people who have labs, and that kind of got the ball rolling on reproduction. And yes, he did sequence it and found all sorts of stuff that doesn't need to be there, and a bunch of stuff that's kind of scary that it is. And that does include this SV40 promoter enhancer thing, because the SV40 enhancer is a known gene therapy tool. It's called a nuclear localization sequence. So it actually, it's a little bit of DNA that traffics stuff to the nucleus of cells. And like I said, it's used as a tool in gene therapy. And this is well documented. This isn't, stuff that's new. If anyone wants to look that up, you can go to David Dean's website. He's like one of the gene therapy guys in the world who's been publishing on this. Why isn't this SV40 promoter enhancer that Kevin mapped onto the plasmid using the SnapGene software? Basically, you have little bits of material, and you can use this software to create, it's kind of like reverse engineered plasmid map. So it shows you like where these elements are on this little circular piece of DNA. The one that Pfizer disclosed as part of a rolling rapporteur report does not show the SV40 promoter or enhancer. It only shows a T7 promoter, which is the one that should be there. This is the one that you use in the manufacturing process and as part of the in vitro transcription reaction. The SV40 does not need to be there at all. And the fact that it does have functionality, which Health Canada, one of the Health Canada reps we have in a FOIA requested email, is claiming outright that it has no functionality with no evidence to support that claim. There's no reason to believe it doesn't have functionality. So the question becomes then, well, what is it doing? Is it trafficking stuff to the nucleus of cells? Is it trafficking these little DNA fragments that we know are in there?
I presume that if it's not doing anything, then it shouldn't be there. I'm just like, I feel like the scene out of Billy Madison, like the SV40 large T antigen is a hexamer protein that is a dominant acting oncoprotein. Onco, I know, has something, I know that from oncology, which is cancer. I don't know what that means. Derived from the polymavirus SV40. None of this makes any sense to me. What does any of this mean, Jessica?
So the large T antigen isn't a part of it. This is more of a problem when you have the whole virus. So we're not talking about the whole simian virus. We're talking about these elements that are basically used in biotech as promoters and enhancers to promote and enhance transcription. Transcription is going from DNA to RNA. So that's what this synthesis process of this modified mRNA utilizes transcription in vitro. That's why we call it in vitro transcription, in order to get that DNA, that starting material into the RNA form.